Hello and welcome to Evolution. As you might have gathered by now, this class is going to be run a bit differently from most, if not all, of the other college courses you've taken. So this video is an introduction to how and why this course is going to be so different. One of the ways in which this course might be somewhat different from other courses that you've taken is that we have designed this course with the purpose of helping you to develop deep learning, to construct deep learning. So what is deep learning? Basically, it's a process by which information is converted to knowledge. So knowledge is not something that we as instructors can give to you. We can give you information, but knowledge is something that is actually constructed by the individual learner to be able to take that information and transform it into something that they can actually use to inform decisions or solve new problems, analyze new situations. And so some of the ways in which you're going to be creating this knowledge or this deep learning is by working on significant problems, to be able to relate and apply knowledge to your everyday experiences, to be able to understand why this information that we're giving you is part of a much, much larger whole that relates to your real life. Being able to not just make, but also be able to explain why you're making decisions or taking positions, to know the reasons for it and be able to incorporate information into making those decisions. In deep learning, it has to be intrinsically motivated. Deep learning doesn't happen due to external rewards. You learn in this deep kind of way because you really care about learning and care about being able to do the kinds of things you can do with deep learning. And it's also part of the process is being able to take your own knowledge and be able to incorporate other perspectives into that knowledge and know how all of these different pieces of information fit together. So this is the goal we're going for. And again, this can only happen if you are an active participant in constructing this knowledge. As it turns out, this sort of active engagement in constructing knowledge is not always something that happens in a typical class session, your typical lecture class. And as an example of this, I'm showing you results from a study where researchers put wearable sensors on a student that measure the activity of their autonomic nervous system. So basically, what you're seeing here is a measure, some sort of measure of their state of arousal, how active their minds and bodies are during different activities. So where you see these spikes, this is a period of sort of high mental activity. And so on this first day, we see maybe not the most engaging lab activity, homework. So this indicates probably that this person was doing some sort of very active, engaging homework problem solving, high level of activity. They then go to sleep. During some periods of sleep, they actually have a fairly high state of arousal. Then they get up and they go to class and nearly flatline. So this first day we've got a little peak of activity level, but in most of these days, if you look, things where they're actively engaged in activity, such as lab, such as homework, early REM stages of sleep where they're probably having very interesting dreams, and then they come to class, and basically their brains are about as inactive or even less active than when they were asleep. Doing chores, pretty mindless, again, comparable to what's happening in a typical class session. Watching television, about the same as being in class. So this is basically saying that these in-class sessions where an instructor is standing up in front of the class and just talking, not a whole lot of learning is happening in that situation. So what we would like to do in this class is sort of turn that around. We want to be having you do more of this kind of stuff. In the class, when we're actually present and we can create a community of learners to support these kinds of activities, this kind of active problem solving right there in the classroom, and take some of this stuff where you're just taking in information and letting you do that at another time when you can sort of do it at your own pace, in your own way, gather in the information, and we're going to spend our time in class building knowledge. So if you're thinking of your education as preparing yourself for some sort of future career, really the best way to prepare for something is to practice what you're actually going to be doing. So if you think about what your future job will look like, is it going to look like this, what you do in a typical college classroom, sitting in seats watching someone at the front make a presentation? Or is it more likely to look something more like this, working together with other people, problem solving, analyzing, actually doing things with information? Most likely it's going to look a lot more like this. And so we're going to be practicing this kind of work in class where you work together in small groups of people to discuss an issue, to discuss a concept, to discuss applications of information that we've given you, to solve problems, to make predictions about outcomes. And the best way to do this is by drawing on all of the collective experience and skills of the people who are around you, using the instructors and the learning assistants who will also be part of this learning community as resources to help guide you through these discussions and through this problem solving. And so this is really going to be practicing in a much more realistic way what you're actually going to be doing out there as professionals in the real world. And it turns out the kinds of skills we're going to help you to develop during the semester are the very things that are highly prized by employers. So this is a list from a survey of employers of their top priorities of things that they hope that students will come away from their college education and bring to their jobs. And so a lot of these are things we're going to be working on a great deal this semester. Effective oral and written communication. In this class, you're going to do a great deal of writing and practice that skill. Critical thinking, analytical reasoning, being able to figure out what things are most likely to be true and correct as compared to other things that may be less well supported by the evidence. That's something we're going to be thinking a lot about. A lot of these skills really rely on the kind of deep learning, knowledge building that we've been talking about here. And you'll notice that nowhere on this list do you see anything about being able to recite facts that you've memorized. Okay? This is not something that is a valuable skill to have learned. And so this skill of being able to correctly identify a multiple choice answer from something that you've memorized is not something we're going to be working on, or something that is a particularly valuable skill for you. Being able to solve problems, being able to make predictions, being able to actually think critically is what we're going to be working on here. And these are the things that you really should be coming away from a college education being able to do. Many of you may be eventually applying to medical school, and I'm sure I'm not going to be the first one to tell you, medical school is really, really hard to get into. So I'm sure you've seen statistics like this. Nationwide, for 690,281 applicants, only about 20,000 of them end up matriculating into a medical school program. So that's about 2.9%. Even here at our medical school at FIU, we've got a very, very, very small percentage, 122 get in out of nearly 4,000 applicants. That's about 3.2%. So what is the main difference between these people and these people? Many of these people have really high grade point averages. Many of them have really great volunteer experience and internships and activities and motivations for what they do. But many, many, many of these students that don't end up matriculating into medical school don't make it because they did not perform well on the MCATs. And so a big reason for that is that in many college courses, they are asked to sort of memorize information, feed it back to the instructor on an exam, and they end up just forgetting that information immediately after the exam, and they don't have the kinds of critical thinking, analytical skills that are going to be absolutely crucial on that very, very challenging MCAT exam. And so that's another good reason to really, really take advantage of all the opportunities we're going to be giving you. And this is not just true for the MCAT, for the GREs, all kinds of pre-professional exams that you might be taking. They're really going to focus on critical thinking skills, on analytical skills, being able to predict outcomes. And so this is a very good reason to really not just skate through these assignments and activities that we're going to provide for you, but really, really engage with them and really, really think them through so that you're going to be able to do these kinds of tasks when you encounter them on exams such as these. So at this point, you may be wondering, how are we going to get there? How do we get to this point of deep understanding, of deep learning, of constructing our own knowledge? And the way we get there is by using a combination of taking in information and doing something with it. All right, you need to have the information, you need to incorporate it, but then you need to actually use it in some way so that that information becomes part of your knowledge base and you do different things with it so that you can see how different pieces of information are connected to each other, how they're connected to all of the things that you already know in your experience of life, and how you can use it to make predictions about what might happen in the future. And so probably you've seen statistics like this that people remember 10% of what they read, 20% of what they hear, 30% of what they see, 50% of what they see and hear, 70% of what they say and write, okay? So this is getting into a completely different way of processing information. 90% of what they do, okay? So look, on this side, we're looking at things that you'll remember, kind of the learning activities, but this is also can be interpreted in terms of what you're able to do, what you're able to do after having that kind of processing of information. And so maybe if you just read the book and hear a lecture, you'll probably be able to recite facts, right? You'll be able to define terms, maybe list 3 important points about some concept. You might be able to describe something. These very low level skills that are important, but they're not really going to get you to those analytical skills, those critical thinking skills that are going to be so highly prized once you leave the university. A little bit higher level, but still in this sort of passive learning part of our triangle, you might be able to demonstrate, apply, practice, which is better. But to be able to get down to these really important skills that are going to distinguish you as professionals in the field of biology, you really need to do some sort of active learning activities to be able to really incorporate and use that knowledge rather than just regurgitating it, just handing it back in the same form. You want to be able to transform that information in some way. And I'd like to make a distinction here in learning activities between input activities where you're basically taking things in, you're reading it from the book, you're listening to a lecture, you're watching a video, you're taking information in, compared to output activities, these more active activities, writing out an explanation of something in full text, explaining a concept to somebody. This is particularly valuable if you're explaining it to somebody who is not an expert in the field or even one of your fellow biology students, try explaining some of these concepts to your grandmother. That way you have to abandon the terminology and really focus on what these terms mean to be able to explain them in real world language that anybody can understand. Creating a concept map will work on learning how to do that so that you can actually visualize the connections between different pieces of information, to be able to incorporate them into a greater whole. And these kinds of activities are what are going to give you the skills that you need to be able to do these things like um, analyze, define, create, evaluate. One of the things you might have noticed about these output activities as compared to the input activities is that they're hard work, right? It's a lot harder to actually write something out and do something, have discussions, do concept maps, really play around with these ideas than it is to simply take them in and do the reading over and over again. Many students, that's the only way they've ever really learned to study, is to just read and reread the book, reread their notes, keep doing all of this input. But really, the way to get to this deeper level of understanding, this deep learning, is to engage. So don't be the schmuck on the escalator going up to the gym. You need to be the one actually doing the reps, doing the hard work. Real learning, deep learning, is effortful. It's hard. Many people think that if they don't just get it immediately, that they're just not good at whatever that subject is, whatever that topic is. I'm just not good at critical thinking. But that's not true. Critical thinking is really hard work, and it takes practice and it takes effort. So if it's feeling like it's coming really easily to you, that might be a sign that you are not really getting to the level of critical thinking, of analysis, where we'd like you to be for this class. So it should be hard work. It should be a lot of effort. It may be frustrating at times, but this is a good thing. This means that you are really getting to a deeper level of learning and you're really engaging with the material in an active sort of way that's going to result in building, constructing knowledge. So it's hard work, but we are here to provide a great deal of support with it. Again, our goal here is to form a learning community so that you have lots and lots of other people to rely on. You have us, the instructors, you'll have the learning assistants, you'll have your fellow students all working together to be active learners, to do this hard work, and to come to this greater, higher level of understanding that is going to be so critical to you in not only your future career, but also just in next semester's classes. You're going to have a much stronger foundation of knowledge in biology on which to build in your next courses. So some of the best things you can do is really be mindful of your learning process. Okay, we call this metacognition. So thinking about learning. Notice what is really helping you to understand and what feels like just more input that's not really taking you to a higher level. Try new activities. Try new ways of studying that you've never tried before. If you've only ever studied by yourself, try studying in a group. If you've only ever highlighted the book and reread what you highlighted, try actually rewriting those notes in full text explanations and be aware of what feels like it's really deepening your understanding and making things click. And really importantly, the hardest thing when you're learning a new subject is figuring out what about it you're not getting. So we've given you lots of tools in this class. We're going to be giving you lots of opportunities along the way for self-testing and figuring out what it is that you know and what you don't know. But you are also responsible for taking that extra step and testing yourself, seeking out review questions and answering them, and really having a handle on where you are with this material. So by using this method of active learning, you should end up at the end of the semester with really deep understanding about the central core concepts of biology that you'll be able to take with you, that will become part of you, that is not something that you're just going to forget immediately after the final exam. And this will be knowledge, real knowledge, to last your entire lifetime.